Hello, everyone, and thank you for joining this session. My name is Hồ Tuấn Đức, and I'm the director of the Asian Center for Water Research. Today, I would like to explain the process of sediment transport in Thu Bon estuary and coastal area of Hội An City using numerical modeling. The information I give you today should help you with understanding the mechanism of the erosion and accretion process in Hoi An Beach. The study outcome can provide essential information for establishing the operation institution and upstream reservoir and sand mining in Busa Thu Bon, as well as recommendations of soft or hard measures to protect Cửa Đại Beach but not leaving the bad effect on neighborhoods. I divided my presentation into 4 parts. I'll start off by giving you the background of this study. Then I'll move on to the main part that will talk about the study area and methods, the model setup, and simulation on sediment transport. I'll end with a summary of some significant results. My talk should take about 15 minutes, and I would be grateful if you could leave any question to the end. So, let me give you a brief overview of the study. Along the coastline of Vietnam, especially in the central region of the country, many beautiful beaches are of significant importance to the development of the central provinces. In recent years, however, coastal erosion has become severely eroded at various beaches that affect the tourism industry and economic losses. Therefore, coastal erosion problems have been a big concern for local management as well as domestic and international scientists. The study area is Cửa Đại River mouth of Busa Thu Bon River Delta, which is located at Quảng Nam Province in the central region of Vietnam. Thu Bon River flows over 200 km on its basin and linked to the Busa River at about 33 km upstream from the Cửa Đại River mouth. Cửa Đại coastal area has a long coastline from Sơn Trà Peninsula to An Hoa Cape. In recent years, coastal erosion on the left side of the Cửa Đại River mouth has become more severe, while the asymmetric shoreline diverts more sediment transport on the right side of the river mouth. In November 2019, a new islands were formed in front of Cửa Đại River mouth and caused a lot of problems for navigation transportation, as you can see in the figure E. These satellite images are taken from Sentinel-2 and Google Earth during the period from 2015 to April 2020. Many studies have been carried out to identify the causing mechanism of the coastal evolution problem in this area, including national and international projects. Some highlight studies are presented in this slide and the references. However, access to the full report of the projects is still limited. For published documents in the last decade, many studies monitor the shoreline dynamics of the Cửa Đại estuary by using field survey data, geographic information systems technique, and multi-temporal satellite remote sensing images. Besides carrying out the field investigation, several numerical models for explanation and prediction of erosion deposition processes were also applied. However, these studies have not focused on the mechanism of formation and loss of sand dunes in the estuary, and further investigation are highly required. Therefore, the current study aims to investigate the mechanism of the eruption and accretion process in Godai Beach in order to provide valuable information for the local authorities to find the best solution for this area. And now I will move on to the section 2. The study area includes the downstream network of Thubon River, a part of the north coast bordering Sunja Peninsula, with a length of about 45 km along the coast and an average width of about 40 km from the shore. The area is about 2,600 km square, including 20 km from downstream river of Thubon system, 5 km along the coastline to the north and the south of the estuary, and 4 km away from the coast. Godai River mouth is a large estuary area where the Thubon River flows into the East Sea. In regard to the climate, these sites belong to the tropical climate zone, which is affected by the cold northern wind and has only two main seasons, rainy and dry. The rainy season mainly occurs between September and December, representing about 80% of the total annual rainfall, and coincide with the tropical typhoon season. This zone is described by over 64,000 unstructured triangular elements, with the largest mass of about 2 km for offshore element, whereas the smallest is about 50 meters for the element in the Thubon River. In this study, we used the open source hydrodynamics software called Telemark 2D, coupling with two-dimensional morphologic module called CSIF and spectral wave propagation module called Tomahawk to evaluate the erosion mechanism in Godai estuary area under the combined effect of wave and tide. Users can interfere with the module using foreground algorithms to achieve specific computational purposes. Telemark models were developed in 1987 by the Electricity of France company, with the participation of many research organizations around the world. The Telemark 2D module is used to simulate free surface flows in two dimensions of horizontal space. It solves the Sine-Brennan equation from number 1 to 3 using the finite element or finite volume method. By means of finite element method, Tomahawk solves simplified equation number 4 for the spectral angular density of wave action, representing the variation of the directional spectrum density. Concerning the sediment transport and bed evolution, module CSIF is used to model complex morphodynamic processes for different flow conditions, sediment size classes, and sediment transport modes. CSIF is applicable to non-cohesive sediment that can be uniform or non-uniform, as well as cohesive sediment and sand mixture. The sediment transport in 2D model is described by the equation number 5 and 6. To set up the model, we use the following data. First, the bed level of this area is needed to interpolate the bathymetry for all the computational mass. Then, two discharge boundaries are applied to two major tributaries located at about 12 km toward the upstream of Godai estuary. Each branch is assigned with relevant discharge rate depend on the study period. The sediment fluxes at the boundary are also defined with 3 particle classes. Next, the river stages on the open boundary in the East Sea is from the astronomical time, with the 9 main waves extracted from the oldest database with a resolution of 1/30 degrees. And finally, the effects of wave and wind are included in the model by using the spatio-temporal variation of wave and wind data from the NOAA database. Let's now turn to the next point. The hydraulics model is calibrated and validated using the monitoring data at some typical locations in the wet and dry season. The model is sensitive to friction, additive viscosity, Coriolis, as well as space discretization. These parameters have to be adjusted to give the best fit to field observations for the same location and periods of time. The simulation duration is taken within 1 month to analyze the shock wave component based on the insignificant impact of the long wave component on the short-term simulation results. In this slide, the upper figure represents the comparison between observed and simulated stages in October 2014, while the lower shows the wave height. The results have a good agreement with the measurement data. And then the model is validated in March 2014. And again, we can observe the consistency between the simulation and measurement data. Tidal waves in both the calibrated and validated periods show that the principal lunar semi-diurnal constituent, lunisolar diurnal constituent, and the lunar diurnal constituent are dominant with an amplitude of about 0.15 meter to 0.12, but there is a variation in phases between seasons. The wave height during wet season can reach up to 2.5 meters at offshore locations, higher than in dry season. And now we move on to the last section, where we discuss the study of sediment transport using the developed numerical model. Let's begin with a video from the model, showing the sediment transport from the Thong estuary to the sea during the rainy season in 2018. So, about the sediment transport, the simulation results reveal that the sand goes in all directions with the highest amount at the estuary. To investigate the difference when the sediment went out of the estuary, we determined the distribution of sediment at 2 positions, one at the estuary and one at a distance of about 1 kilometer along the river axis. We noted a more significant sediment rate in the north, whereas the sediment is shifted very far to the south coast of Kedai, although with a low amount. Concerning the bed morphology evolution, the simulation of sediment transport for rainy season versus dry season are presented. The results show that erosion occurs mostly in the north coast of Kedai estuary and happen more seriously in the northeast monsoon periods, with the maximum erosion depth of about 0.85 meter. In addition, sedimentation is formed in the offshore of Kedai toward Cù Lao, which is consistent with the observed situation in recent years. One of the factors that can be detrimental to the phenomena of coastal erosion in Hoi An comes from the action of waves. To elucidate the influence of this factor, we stated a scenario during rainy season in which the wave effect is ignored. Comparison of the results between two scenarios with and without wave show the crucial role of wave in coastal erosion phenomena in Hoi An City. In the case of ignoring the influence of wave on the Hoi An coast, especially on the northern shore, the erosion is greatly reduced and the beach is almost sterile. In closing, I will just summarize the main points we have looked at. The simulation results show that the main trend of coastal currents caused by tide and wave tend to go southward, leading to coastal erosion in the north coast, especially during the northeast monsoon season, with a rate up to 1 meter in October 2014. This is not the case for estuarine area, with a sediment transport up about 0 and sedimentation of about 0.3 meter is observed. In addition, the model also showed the crucial role of wave in shoreline erosion, with the degrees of erosion in the north coast near Kedai being more severe than the southern coast, through the formation of local eddy flow on the north coast. The simulations have been performed at the High Performance Computing Center in Ho Chi Minh City University of Technology. This research is funded by Vietnam National University Ho Chi Minh City. We would like to thank SMUT and VNU for the support of time and facility for this study. And then here is the list of some highlight studies that I mentioned before. And that brings me to the end of my presentation. I would like to open the floor for any questions that you might have. And thank you for your attention.